Hello students, during our last day's class, we were learning regarding the different kinds of sets. We just started with the empty set, then we had a representation of empty set. Now today's class is the continuation of our previous class regarding the different types of sets. So from this group, today we are going to learn about mainly three kinds of sets. The first kind is called finite set. Check the spelling, F-I-N-I-T-E set, finite set. Then what's the meaning of finite set? Is another question. Finite set is that set which contains only a limited number of elements, limited. The same sentence we are writing down in a different way. A set consisting of definite number of elements. The same meaning, definite number means we are able to count and say exactly how many elements are there in a set. How many elements are in a set. We can easily count and say. Take an example of your class. The number of students studying in your class. We can easily count up. It can be 30 or 35 or 40 or 45. So there is a fixed number. The same way in the class or in a set when we take, the number of elements can be counted and we are able to say how many elements are in that particular set. And if you are able to count it that way, that set is known as a finite set. There are so many examples that you can see around our normal life. So many sets that we can find in the classroom, even outside, at your home or with you. We can find so many sets of this kind. And this is a simple example we are going to put it down. A is equal to set of x such that x is a day of a week. Last day we have seen that this way, this method is known as the set builder form. And if you want to learn something about that, you just see the main portion of that set. X is a day of a week. So X must be a day, any day, no problem. And it must be a day of a week. So if you are asked to list down the days of a week, it becomes A is equal to. The first day could be Sunday, then Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So when you write that such A, we are having 7 elements altogether. Or we can write as n of a is equal to 7. In other words, the number of elements can be easily counted. These kinds of sets are known as the finite set. Take another example from your classroom. The number of teachers teaching in your classroom. If you make a set, you can just write the English subject, who is teaching that English subject, that teacher's name, second subject, third subject. Like this, you can create a set, then check whether you can count the number of elements in the set. Definitely, you can come down. So that's it. Again, another example of finite set. Like this, so many sets we can find, but only one condition that the number of elements can be counted. We can count it correctly and say how many elements are inside. It's just opposite could be now our next set, known as infinite set. Infinite means which is not finite. So if you are asked to write down a definition for it now, a set which is not finite, that is enough. A set which is not finite will be an infinite set. In other words, the number of elements of a set cannot be counted. We are not able to count exactly how many are there inside. So many elements are coming inside and we are not able to count up correctly. So that will be now, always now, an infinite set. There is another example, see, b is equal to set of x such that x is a point on a line. Imagine there is a line being drawn on a surface. When you just draw a line, so many points are needed to create a line. Another question, x is a point on a line. How many points would be there on a line? Possible to count up? No. Why? Because the line is extended indefinitely on the both sides, the both direction. So we are not able to say exactly how many points are there on that particular line. That's why n of b, or the number of elements in b, we are not able to find correctly how many points are there. So that's will be an example for the infinite set. Another one, set of natural numbers. You write in the roster form, n is equal to. We can write 1, 2, 3, 4, 5. After writing down a few elements, we are not able to write all the one. There is only one way. We are going to put a few dots, some 2 or 3 dots. We are going to put it up. So that becomes 1, 2, 3, 4, then etc. etc. We can put it down. It shows that the elements are not getting ended. The last element, the final element, we are not able to say what it could be. That's why that set becomes now an infinite set. Same way, the set of whole numbers, that becomes set 0, 1, 2, 3, etc. The last element, the final element of the set cannot be predicted, cannot be set, cannot be written down. So that would be now an infinite set. One extremely important point to be noted that almost all the infinite sets cannot be written in roster form. If it can be, but if it take a set, for example, if it is infinite, you can write a few elements, the first, second, or third, but you can put 2 or 3 dots that will represent an infinite set. But when you write the set along this way, we will come to know that all the infinite sets cannot be written in this way. You can't. Take an example of this way. R is a set of real numbers. If you are going to write or convert into roster form, we are not able to write in that special manner because the elements may not be having a regularity. There is no strict pattern of the elements. As a result, that set you can't write. You can write only in the set builder form, that is R is equal to set of x such that x is a real number. Backward direction, that means to convert into enumeration form is not that easy for it. At the same time, think that you have learned an empty set in the last day's class. Empty set. Always keep in the brain that an empty set is always a finite set. What's the reason? When you write an empty set, we normally write it as A is equal to, you put a pair of brackets without any element. How many elements are there? No elements, which means number of elements becomes 0. N of A is equal to 0. So since we have a number there, that becomes always a finite set. So empty set is always a finite set. Then it becomes a new group known as equal sets. Equal sets. Two sets are said to be equal if they have exactly the same elements. A beautiful definition. Two sets are said to be equal. You take two sets A and B, or C and D, or E and F. Two sets, you need to say that, are exactly equal. And what's the condition? They should have exactly the same element. Same elements must be in both sets, A and B. Then only A and B can be equal set. If they are equal, we write as simple as A is equal to B. If they are not equal, otherwise, you write A is not equal to B. So these are the main groups that we have to learn about the varieties of sets. We have learned about empty set. We have seen today the finite set. We have heard about the finite set, and also we learned something about equal sets. And using this concept only we can go for now for the next program. On the right hand side of the green board, we have something around 9 questions of different quantities. Let's see the first question. Which of the following sets are finite or infinite? We have got 9 different sets. When you come back tomorrow, you browse it over correctly and check it whether you can find the answer for these questions yourself or not. If you don't get the answer, why not? We will be able to discuss in the same class, the same pattern, but make it try. What's the first one? A is equal to the set of months of a year. Set of months of a year. You need to say whether that set is finite or infinite. B is equal to set 1, 2, 3, etc. Some dots are put it down. You need to say whether this set is finite or not. C is equal to set 1, 2, 3. After some dots you can see there is a number, say last 11 is 100, which means the 11s are ranging from 1 up to 100. 1, 2, 3, 4 up to 100. You need to say that whether C is a finite set or infinite set. D is equal to set of positive integers greater than 100. Set of positive integers greater rather than 100. Can that set B be finite or not? Another set of x, they are also given as again D only. Set of x as that x is a prime number, x is less than 99. If you combine these two lines together now, you need to find a prime number. This prime number must be always below, less than 99. Can this set D be a finite or not? E is equal to set of x such that x is a line parallel to x-axis. X is a line parallel to x-axis. Over your brain, you thinking about your x-axis, y-axis in a plane. Then you are going to draw a line, and the line should be a parallel line to the x-axis. So if you write or if you make a set, can that set be finite set or not? The next one is now the set F. X is such that X is a letter from English alphabet. X is a letter from English alphabet, which means X must be from the language of English. You have to say that whether the set can be now a finite or not. G is equal to set of x such that x is a multiple of 5. Thinking about that set and tell me when you come back tomorrow whether that set is finite or not. If it is finite, why? If it is infinite, how? X is the next set of x, that x is a circle passing through the point 0, 0. So you select the circle which should pass through the point 0, 0, and you make a set, and can this set be finite or not? So that is your homework for tomorrow. Make it try and come back with a prepared brain for tomorrow's class. That's all for today. Thank you.